Hello, welcome back. We're going to do lesson 6.1 today, which is all about the law of sines. You guys have used the law of sines before in geometry and also maybe in algebra too. So hopefully it's not super new, but maybe the applications that we're using it for will be new today. So we have three objectives. The first objective is to use the law of sines to solve oblique triangles. Then we're going to find the areas of oblique triangles. And then we're going to use the law of sines to model and solve real life problems. Okay, so the first thing that we're going to do is we're just going to review how do we use the law of sines. So I'm going to scroll down here. So the law of sines is helpful because you don't need a right triangle to use the law of sines, right? If we want to use SOHCAHTOA or those trig functions, right, we have to have a right triangle. But in the law of sines, you don't have to have a right triangle. So that's really helpful. And so we're not going to derive the law of sines, so don't worry about all this stuff. This right here is what we're after. This is the law of sines. And you can use any combination of two. So you can say you can use A and B, or A and C, or B and C. Okay, any combination of those is fine. And then this question here on the left just says, what must you know about a triangle in order to use the law of sines? Well, let's just say that I know A and B. Like, let's just use this. Let's say I'm using this one. Okay. So I would have to know 3 out of 4 of these pieces, right, in order to be able to do law of sines. Remember that my capital letters are angles and my lowercase letters are sides. So I would have to know like an angle, side. If I knew 2 angles and 1 side, I could do that, right? Also 2 angles and 1 side can be written as angle, side, angle, okay? Or if I know 2 sides and 1 angle, so if I do like side, angle, I also would be able to find the 4th piece of information there. So as long as I know 3 out of the 4 pieces, then I'm able to use law of sines. And what I always say is, do I know an angle and the side across from the angle, right? So like, do I know angle A and the side across from the angle, side A? If I do, then I can use law of sines. So if I know angle A and side A and one other piece of information, I can use law of sines. Or if I know angle C and side C and one other piece of information, I can use law of sines. And then same thing with B. So I think when we actually do this, the light bulb will go off and you guys will remember and you'll be like, oh, that's not so bad, right? So here I have in triangle ABC, angle C is 102.3, angle B is 28.7, and side B is 27.4 feet. Find the remaining angles. So I would just want to solve this triangle. So there's my triangle, A, B, and C. Okay, so C is a 102.3, B is 28.7, and side B is 27.4 feet. So the question again, I always ask myself, do I know an angle and the side across from the angle? And in this case, the answer is yes, right? I know an angle and the side across from the angle. So I'm going to go ahead and make my list, right? Because it wants me to solve the triangle, which means I have to have all 6 pieces. I know that angle B is 28.7. I know that side B is 27.4. And I know that angle C is 102.3. So angle A should be really quick and easy to find, right? Just subtract it from 180 and we should get 49 degrees. Okay, because I know an angle, and the side across from the angle, I can use law of sines. So it's going to be sine of the angle that I know, so 28.7, divided by the side across from that, which is 27.4. And this equals, now I have to decide, do I want to solve for A first, or do I want to solve for C first? It doesn't matter, but you just need to know, right? So let's go ahead and solve for A first. And so I'm going to have sine of A, and the angle A is 49 over side A. And then here I just cross multiply. So I have A times the sine of 28.7 equals 27.4 times sine of 49. Divide both sides by sine of 28.7, so A equals 27.4 sine of 49 divided by sine of 28.7. Make sure that you are in degrees on your graphing calculator, right? Because these angles are given to you in degrees, so it has to be degrees, so just make sure you're paying attention. And I get that side A is about 43.061 feet, or you could say just 0.6 if you want to. So 43.061 feet. Can't forget our units. Okay, so I've solved for A. Now I'm going to do the exact same thing for B, or for C, excuse me. So I'm going to take my sine of the angle I was given, 28.7, divided by the side across from it, so 27.4. So that's the same. But now I'm going to solve for side C, so I have to use angle C. So now I'm going to have sine of 102.3 over side C. Now I'm going to do the same thing. I'm going to cross multiply, and I get C equals 27.4 sine of 102.3 over sine of 28.7. Enter that into my calculator, and I get that C is about 55.747 feet. 55. So here then I have solved for the triangle. Remember that solving means that you need all 6 pieces of the triangle. So just a quick refresher on law of sines. Personally, I prefer it over law of cosines if possible, just because it's just cross multiplication and entering things into your calculator. But we will talk about law of cosines on the next video. Okay, so let's look at the next example. As always, if you have any questions on any of these examples, make sure that you reach out and let me know, and we can go over them. Okay. Example 2 says a pole tilts towards the sun at an angle 8 degrees from the vertical, and it casts a 22-foot long shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. Okay, so here's the sun. Ew, right? There's the sun. Okay. And then I have this pole that's tilting towards the sun. And it's tilting at 8 degrees from the vertical, which tells me that this right here is 8. And then the pole casts a 22-foot long shadow. So here's the shadow. And then from the tip of the pole, from the ground up, the angle of elevation is 43 degrees. So this is 43. And I want to know how tall is the pole. Well, no x. Okay, so there's a lot of stuff going on here. I don't even know, right? I don't have enough angles to figure out other things. Do I know an angle and a side across from the angle? No, I don't, right? Um, but I do see that this 8 degrees makes a right triangle. So I know that that's a right triangle, which means that this guy right here is 82, right? Because I'm just using that as a right triangle. Okay. Now 82 and this angle make a straight line. So I subtract it from 180 and I get 98. So that's 98, which means that this is 43, 98. This is 39 degrees. Okay. So now, do I know an angle and a side across from the angle? Yeah, well, the only side I know is 22 feet, and the angle across from that is 39. So I can use law of sines now. So I can say that sine of 39 over 22 equals, and this is what I'm trying to find. I'm trying to find x. So I want to use the angle across from that, which is 43. So sine of 43 over x. And so now I'm just going to cross multiply and solve. So x times sine of 39 equals 22 times sine of 43. Divide both sides by sine of 39, and I get 22 sine of 43 over sine of 39. Plug that into my calculator, making sure my calculator is on degrees and not radians, and I get x is about 23.842 feet long. So the pole is about 23, almost 24 feet long. And that's it. Hopefully, again, that makes sense. Nice little review of using the law of sines. Reach out if you have any questions on that, because we're going to do the ambiguous case, meaning if you're given a certain type of information, there's actually multiple options on what you could get for your triangle. And so we're going to go through those options here. Okay. So if in a triangle, and I'm going to scroll down just a little bit more. Let's see if I can get all of these in. Okay, we might just do the first 4 and then clear it. Okay, so suppose you have a triangle, something, right? A, B, C. If you're given the measure of angle A and side A, and then also side B, it does not have to be A, and B. It could be C, C, and A, right? Or it could be B, B, and A, or B, B, and C, or whatever, right? As long as, if you're given an angle, the side across from the angle, and one other side, that's what we're getting at here. So it doesn't have to be A, and B. It could be B, B, and C, right? It could be B, B, and C. It could be B, B, and A. It can be C, C, and A, or, whatever. There's all sorts of combinations. Okay, so if you're given that, there's multiple options here. If angle A is acute, so if angle A is less than 90, okay, and side A is less than side B, so this is case 1, okay, what happens is I have a triangle, and who knows how long this goes, it doesn't matter. Okay, when you solve, right, you'll do all the work, you'll do law of sines, you'll solve, and you'll get an error on your calculator. Okay, so you'll get an error when trying to find angle B? Because no triangle exists. So this is angle A, and then let's call this B, right? And this is C. No triangle exists here because side A, or side B, and side A are different lengths. A is smaller than B. A will not reach vertex B. So there's no triangle I can make here with this information. And so when you're solving for B and you get error, it just means that there is no triangle that exists. Okay. In case 2, if A is less than B, and you solve, and you get that the measure of angle B is 90 degrees, okay, that means one triangle exists. So here's A, right? What that means is that B is 90 degrees. And that's okay. And side A is still less than side B. So if you solve, and you get angle B as 90, then there's one triangle. And you just keep solving for angle C, then side C or whatever, right? You just keep solving like normal. If, excuse me, if A is less than B, and and you get angle B is acute. Okay, so if you solve, and you get angle B equals 26 degrees or whatever, that means that there's two triangles. So then your second angle B is supplementary to the first angle B. So if I solve, and I get B is 30 degrees, then that tells me that my other B is 150 degrees because they have to add to 180. So that actually means that there's two triangles, and this one's a little bit harder for me to draw, so my apologies in advance. So here's angle A. So what this means is I could have this be an angle B. This is side B here. And this is side A, okay? Or this length A can swing around and I could have another B. This is also A. So there's actually two triangles. One triangle here, and that's when the B is obtuse, and then the other triangle is here. And that's when B is acute. So that's just how we're getting two triangles. Okay, so that's case 3. And then case 4 is if the length of side A is longer than the length of side B, then there's just one triangle. So something like that. Right, so this is A. If B is longer, or excuse me, shorter than A, then there's just one option. So those are the 4 options if the angle that you're given is acute, so less than 90 degrees, okay? Again, it doesn't have to be angle A. It can be whatever angle you're given, okay? So just keep that in mind. What about if the angle you're given is obtuse, right? If it's greater than 90. If the side that you're given that corresponds to that angle is less than your other side, then no triangle exists. So right here, this is really important. If A is less than B, no triangle exists. And this is case 5. So what this looks like is, this goes on forever. I'm going to call this A. A is obtuse, so it's going out here, right? So if this is side A, and that's shorter than side B, there's no way that that is going to reach all the way down here. Okay, so there's literally just not enough side length to make the triangle. If A is bigger than B, then case 6, then there's one triangle that exists. Then here's A. It's obtuse, right? And if A is longer than B, then it will go ahead and reach all the way down here to angle B. Okay, so hopefully that makes sense. That was a lot of information. And so we're going to do some practice of this here. And I'm going to show you specifically, like on a graphing calculator, how you can use the store feature to really help you stay accurate on these. So let's go ahead and look at example 3. Okay, so example 3 here says in triangle ABC, A is 22 inches, B is 12 inches, and angle A is 42 degrees. Find the remaining sides and angles. Okay, so A is acute, so that means, so the angle I'm given, it doesn't always have to be A, but the angle I'm given is acute, so it's going to be case 1, 2, 3, or 4. Okay? And then the side that associates with the angle given, 22, is greater than the other side. So that tells me that this is case 4, right? Because A is greater than or equal to B. So the side I'm given is that associates with the angle is greater than the second side. And again, I am a very visual person. So I like to draw things out. It really helps me. If it doesn't help you, then you don't have to do it. But I know personally for me, it really helps. So, okay, so A is 22 inches. B is 12 inches. Then obviously this is not drawn to scale, but that's okay. And I want to find the remaining sides and angles. So I'm going to make my list, right? Angle A, angle B, angle C, and then side A, side B, side C. So angle A I know is 42 degrees. I don't know any other angles. I know that side A is 22 inches. Side B is 12 inches. Then the question is, do I know an angle and the side across from the angle? Yes, I do, right? I know A and the side across from it. So I can use law of sines. So sine of my angle divided by my side equals sine of my angle. Well, in this case, I know side B, so it has to be angle B over my side. And we're going to cross multiply and solve. So 12 times sine of 42 equals 22 sine of B. Always keeping in mind we want this B, so I'm going to divide both sides by 22, so 12 sine of 42 divided by 22 equals sine of B. But I want the B by itself, so I have to take the sine inverse. So the sine inverse of 12 sine 42 over 22 equals B. And so what I'm going to get here is I get that B, and make sure you get in degrees, right? B is about 21.5 1.406 degrees. And so what that does is I'm going to end up saving this. So let's go to my calculator. Okay, so I'm in degrees, so I just did sine inverse of 12 sine of 42 divided by 22. I'm going to close it and hit enter. So there's my 21.406, right? I'm going to store this as alpha b because that's what it is. It's b. Then to find c, right? C is just going to be 180 minus a minus b. So now I can just do, if I go back to my calculator, 180 minus a, which is 42, minus b, and I'm just going to use b because then it doesn't round. And I get 116.59. And I'm going to store that under C. Okay, so that is now C. So I have angle B is like 21.406. Ooh. And then C was like, holy moly, where is it? What was it? 116.594. 116.594 degrees. Okay. Now the last thing I need to find is side C. So I'm using my law of sines again. Sine of 42 over 22. You can use 21.406 and 12, but one, it's not exact. And two, what if you calculated it wrong in the first place? Then you're going to just be calculating it wrong again. So I like to use the information that's given to me. And then sine of C, which I'm going to use, I'm going to actually plug in C. So that's actually a number. So I have C times sine of 42 equals 22. Sine, remember C was like 116-ish. Divide by sine of 42. So I have 22 sine of 116.594 divided by sine of 42. And when I enter this into my calculator, I am going to be very careful about using the value of C here. So watch what happens. So I'm going to do 22 sine of alpha C. So now it's taking this number and it's using the exact number. It's not rounding. Okay. And then divided by sine 42. And I get 29.4. So C is about 29.4 inches. So there is a benefit there in storing your values under or like in your calculator, because then when you're actually using those values to calculate things, you're not having to use a rounded number, you're using the exact number. Okay, let's look at example 4. In triangle ABC, show that there's no triangle. Okay, so A, B, C. A is 85. Side A is 15. Side B is 25. Okay, so the angle I'm given is acute, so it's going to be case 1, 2, 3, or 4. Okay, and then the side associated with that angle is less than the other side. So A is less than B. So it's going to be case 1, 2, or 3. So there could be no triangle, there could be one triangle, or there can be two triangles. We don't know. So we will have to find out. Okay, so here, do I know an angle and the side across from the angle? And the answer is yes, so I'm going to go ahead and solve. So I have sine of 85 over the side, which is 15, equals sine of my angle, angle B, over side B, which is 25. And we cross multiply and solve. So 25 sine of 85 equals 15 sine of B. So let's go over here. So I have 25 sine of 85 divided by 15. So I'm going to divide both sides by 15. And that equals sine of B. Then to get B by itself, we have to take the inverse. So that gives me sine inverse of this whole thing. So 25 sine of 85 over 15 equals B. Okay, so we're going to enter this in our calculator. Again, make sure you're in degrees, right? So sine inverse of 25 sine of 85 divided by 15, close it, and I get error. So because I get error, it's going to be case 1, right? So I get B, and it says error. So it's going to be case 1 where there's no triangle. So there's no triangle that exists. The lengths don't match up. There's no way that I can draw a triangle with these lengths. Okay, so hopefully that makes sense. We're going to try another one. It's going to be the last one that we try, and then we're going to switch up and do area. Okay, so example 5, it says in triangle ABC, find two triangles for which A is 12, B is 31, and angle A is 20.5. Okay, so angle A is acute, so it's case 1 through 4. And then the side that associates with that angle is smaller than the other side. So A is less than B. So it's going to be either case 1, 2, or 3. We don't know yet. So I'm going to draw it because, again, I'm a visual person. So A, B, and C. Angle A is 20.5. Side A is 12, side B is 31. Oh, and don't forget units. Okay, and I want to know what is angle A, what is angle B, what is angle C. And then I also want to know what is side A, side B, and side C. So I'm going to fill in what I know so far. I know that this is 20.5 degrees. I know that side A is 12 meters, and I know that side B is 31 meters. So I'm going to use my law of sines to find side B. Sorry, angle B, right? So sine of my angle over the side equals sine of my angle over the side. We cross multiply. So 31 sine of 20.5 equals 12 sine of B. Divide by 12, 31 sine of 20.5 divided by 12 equals sine of B. And then you just take the sine inverse. So sine inverse of all of this, 31 sine of 20.5 over 12 equals B. And I self-solve, I plug it into my calculator. Let's do it, right? So clear this. So sine inverse of, let me do it, oh here, 31 sine of 20.5 divided by 12. And I get 64.78. So let's just leave it at, right, 64. 64.78 degrees. Because this is an acute angle, okay, there is another triangle. There is a second triangle that works here. So because B is acute, there is a second triangle. But before I find the second triangle, I'm going to do all the work for the first triangle, okay? So this is just the first triangle. So I'm going to take this B value and I'm going to store it under B. Okay. Now I can find C easily, right? I do 180 minus 20.5 minus B. And I get 94.72. Let's do 94.72 degrees. Okay. And then now I can use law of sines again to find side C. So you can do sine of 20.5 over 12 equals sine, and I'm going to store this one, sorry, I'm going to store this under C, just so I don't lose it. Sine of 94.72 over C. And I'm going to do some cross multiplying and simplifying it down a little bit more. So I get C is equal to, when I cross multiply, I will get 12 sine of 94.72 over sine of 20.5. So I get C is about, now remember when I enter this, I'm not going to enter 94.72. I'm just going to enter C. Okay, so I have 12 sine of C divided by sine, I don't remember what it was, sine of 20.5. And I get 34.15, let's just say. 34.15 meters. So that is one triangle. Okay. Now, I know that there's a second triangle. I know that there is a second triangle. So I'm going to go ahead and write down the information I need for the second triangle. A is still going to be 20.5. That's not going to change. Side A is still going to be 12 meters. Side B is still going to be 31 meters. Angle B now is going to be the the supplement to this angle B. Okay, so we just do 180 minus this. And remember, we stored this in our calculator, so I can just do 180 minus B. And when I get 115.2, let's say 22. 115.22 is the other angle B. So my two angle B's have to add to 180. Sorry, my knee is going numb. Okay, so now I'm going to save this as my new B. I'm going to store this under B because now I'm talking about B for my other triangle. So now I can do 180 minus 20.5 minus B, because it's my new B, and I get 44.28. 44.28. And that is my new angle C, so I can store that under C. And now I can just do law of sines one last time to find the side C for the second triangle. So sine of 20.5 over 12 equals sine of 44.28 over C. And again, I'm going to go ahead and just do a bunch of this in my head. We will get 12 sine of 44.28 over sine of 20.5. And remember, I'm not going to enter 44.28. I'm going to enter C. Okay, so let's go back and I have 12 sine of C divided by sine of 20.5. And I get 23.92. So that 23.92 meters is the length of my third side. So here are the two different triangles that are created with these three pieces of information. So here, again, I have two options of triangles. So if you solve and you get B as an acute angle, there is another triangle that you will have to find. So just make sure that you're paying attention, and that you're constantly asking yourself, is there another triangle? All right, the last thing we're gonna look at here, sorry, not the last thing, almost the last thing, is finding the area of an oblique triangle by using sine. Okay, so again, we're not gonna worry about deriving the formula of finding the area of an oblique triangle, right? So in an oblique triangle, I can't use base times height divided by 2 because I don't have a height. Typically, I don't have the height given to me because it's not a right triangle. So we're not going to necessarily worry about deriving it. This right here are the formulas that you need. Okay, so notice I'm given an angle and then I'm given the two sides not associated with that angle. So any of these three formulas, they're exactly the same, but just know you're given an angle and then the two sides not associated with that angle. So here it says, what must you know about a triangle in order to use this formula? You have to know side angle side. It's your only option, okay? The angle has to be between the two sides. It has to be included. I think you'll find that the actual formula, right, it's not hard to use. You're just plugging in values. You just need to make sure that you're plugging in the right values. So I'm going to scroll down and we're going to try it. Okay, so example 6 says, find the area of a triangular lot having two side lengths of 90 and 52 and an included angle of 102. So here it doesn't have a triangle or anything. You don't need one. It's telling me that the included angle is between the two sides. So that just tells me that my area is equal to 1/2 times both of my sides multiplied together, and then times sine of my angle. Remember, your angle always goes after sine. So I'm just going to enter this whole thing into my calculator, making sure that I'm in degrees. Check your work here. If you need to pause the video, that's fine. You should get 2288.865. And then don't forget we're finding area, so it's going to be meters squared. So don't forget your units squared here. I want you to try this one. Go ahead and pause the video and give it a shot. If you need to draw it, that's fine too. But pause the video and then when you're ready to go over it, hit play. Okay, so again, I'm just going to draw this. Hopefully you guys gave it a shot. It doesn't do you any good unless you try it. Here's DEF. Given the angle E is 20, given that side D is 5 and side F is 9. So I have side angle side, so I'm good to go with this formula. I have area equals 1/2 times one of my sides times the other side times sine of my angle. And again, I just enter the whole thing into my graphing calculator and check your work. You should hopefully get 7.695 centimeters squared. Don't forget your units squared. Okay, so hopefully not so bad. I know that equation is like, oh, that's easy, right? Which is great. We just want to make sure that we're paying attention and that the angle is between the two sides, or else this formula does not work. Okay, we are on the last page here, so we're going to review some stuff. We're going to review bearings first. Okay, so in order to review bearings, illustrate the following. So I want you to pause the video and try this. And then when you're ready to review your work, go ahead and hit play and we'll go over it. Okay, so let's review. Remember that when you're talking about bearings, you always start from the north-south axis. So here it's telling you to start on the north, and then you're going to go 28 degrees west. Well, west is to the left, right? So, and I'm just estimating 28 degrees, like it doesn't matter. 28. So that would be your bearing. For B, it's north, and then you're going to go 15 degrees east. So this right here could be 15. For C, you're starting on the south, and you're going west, and you're going 68 degrees west. So this right here would be 68. And then D, you're starting on the south axis, and you're going 83 degrees east. So you're going this way, 83. And that's it. So just a nice little review. Remember, you always start from north-south, and then you go whichever direction it tells you to go in however many degrees it tells you. Okay, so let's look at a problem that involves bearing and involves sine, and I think we'll have some fun. Okay, so let's read it. A course for a boat race starts at point A and proceeds in the direction of south 52 degrees west to point B, and then in the direction south 40 degrees east to point C, and finally back to point A. Point C lies 8 kilometers directly south of point A. Okay, so I'm going to start with where it starts. It starts at point A, right? And then I'm going to draw my north-south axis. Boom. Okay, and it goes southwest 52 degrees. So it goes this way to point B. So this is 52 degrees. Then on point B, it turns and it goes southeast back to point C. And it goes southeast 40 degrees. So this right here is 40. Okay. And I know that A and C are 8 kilometers apart. And that's literally all I know. So I know that this is side A, I know that this is side C, and that's it, right? Whoosh. Okay, so let's see if there's a couple things that we can figure out. If I knew angle B on this inside, then I could use law of sine. So I'm going to see if I can find that. I am going to draw this line. Let me do it in a different color. That is perpendicular to line AC. So that's kind of what that has done is it's created 2 right triangles for me. So this is 52, this is 90. That tells me that this is 38. Okay. So hopefully that makes sense. We're good there. Then I also have this right angle right here, right? This is perfectly vertical and this is perfectly horizontal. So if this is 40, then I know that this right here is 50 because it has to make a right triangle. Okay, so that tells me that this whole distance is 88. Okay, so hopefully that makes sense. So now what I want to do is I need to find A. So my goal is to find A, and my goal is to find B and C. Because I want to know the total distance of the race. Well, I know that side B is 8. So that's neat. Okay, so I really just need to find A and C. So let's go ahead and find A first, because now I know an angle and the side across from an angle, right? I know 88 and 8. So I can do sine of 88 over 8 is equal to sine of angle A, which is 52, over side A, which I don't know. So I'm going to solve, and I get A is equal to 8 sine of 52 over sine of 88. And then that's something that I can enter into my calculator and check your work to make sure you're entering it correctly. I should get about 6.308 kilometers-ish. Okay, so there's A, 6.308 kilometers. Okay, now I need to do C, but in order to do C, I need to know angle C. Well, I know that this is 52 and this is 88, and the three angles of a triangle add to 180. So that just tells us that this is 40. So now I can use law of sines. So I'm going to do my sine of 88 over 8 equals sine of 40 over, oops, not B, excuse me, over C. Right? Cross multiply, I get C is equal to 8 sine of 40 over sine of 88. I'm going to enter this into my calculator, solve, check your work, and C is about 5.145 kilometers. 5.145 kilometers. So then I'm just going to add all of this up, right? A plus B plus C is about, and I actually haven't done it yet, so let's do it, right? 6.308 plus 5.145, oops, 145 plus 8. And I get about 19.453. 19.453 kilometers is the distance of the whole race. So we can use the bearings then to help us, figure out these real world problems. Our last one is a you try, so I want you guys to try it. It's about the redwoods. So it says redwood trees in California's Redwood National Park. If you haven't been there, it's crazy. You should go. The trees are massive. Anyway, they're hundreds of feet tall. You are in the park and wondering about the height of one of the trees. Where you are standing, the angle of elevation to the top of the tree is 37 degrees. You move 100 feet closer, and the angle of elevation is now 44 degrees. Find the height of the tree. So I'm going to help by drawing. Okay, so here is the tree. Not my worst drawing. Boom. Okay, there's the tree. I want to know the height of the tree. Okay, so you're here. and you look up at the top of the tree. Oh, this is going to be the hard part. Close enough. You look up at the top of the tree, and the angle of elevation is 37. Cool. Okay, then you move 100 feet closer. And now the angle to the top of the tree, the angle of elevation is 44. And you want to find the top of the tree, or the height of the tree. So my hint to you is that you may have to find a lot of other pieces before you can just jump right to H. So keep that in mind. And so go ahead, pause the video, start filling in things that you can find, and when you're ready to go over it, hit play. Okay, so hopefully we just started filling in things that we could find. Hopefully we found that this angle right here was 136. I know that because these add to 180, which means that this angle is 7. So I have all 3 angles in this triangle and one side. So I have enough information here to find another side. So let's find that side X, because then if I know that side, then I can find this third side too. Or I can find H. Sorry, I'm blanking. So I can do sine of the angle I know, which is 7, divided by the side, which is 100, equals sine of 37 over x. Solve. I get x is equal to 100 times sine of 37 over sine of 7. Okay, and I solve, and I get x is about 493.81986, blah, 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 blah. Regardless, I'm going to store it. So I'm going to actually do it on here, right? So I have 100 sine of 37 divided by sine of 7. And I'm going to store this under x, just because that's what we use to find our number, but it doesn't matter. You can store that under whatever you want. Okay, so now I know this value. And now I have a right triangle. So if like I were to draw it on its own, right, this is like 493, blah, 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 and this is 44, and I want to know this. So I have opposite and hypotenuse. That's sine, right? So sine of my angle is equal to opposite over hypotenuse, which is the 493 point blah, 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 blah. Okay, so that just tells me that H is equal to 493.8 blah, blah, blah times sine of 44. So H is approximately, and I'm going to use my X on the calculator. So when I go here, I'm going to do alpha X times sine of 44. And I get that it's about 343.036 feet. So 343.036 feet is the height of the redwood tree. I'm sure some of them are even bigger than that. Okay, please, as always, let me know if you have any questions. I know that was a lot of information. If you have any questions on the examples that we've done, if you have questions on your assignment, if you just need help, make sure that you reach out. I'm available to Zoom really frequently. You guys know the drill. So it's all good. Reach out if you need help. I'll see you later.